You're riding it, dude! Check it out! Okay, grab shell, dude!
Grab what?
Righteous! Yeah! So, what brings you on this fine day to the EAC?
Well,
So we saw in the Nemo clip that the turtle says, so what brings you here to the EAC? And if you go back in that clip, you'll see at one point they show like a light part within the ocean. So currents are really like a river of water within a body of water. Now, we've had a lot of tragedies in currents, especially around Belle Isle. There are very strong currents where the lakes go to a river, the Straits of Mackinac. Currents can be very, very strong. In fact, we have the strongest current in the world called the Gulf Stream. And this current brings very warm water over to Northern Europe and actually causes Northern Europe to be much warmer than it should be. We have another current, the California current, which brings cold water from the north, and therefore the Pacific Ocean in that area is much cooler. So, why are there currents? There are currents because there are differences. There are temperature differences in the water, and there are salinity differences in the water. Let's look at just some salinity differences. I've got three waters here. I've got tap water, which is no salinity. I have 50% saturated water, and I have 100% saturated water. So I have three different salinities. 100% saturated. That means I took water, I poured as much salt as I could in, I boiled that water, and then poured off that, I poured as much salt as would dissolve. Okay, I didn't just pour gobs of salt in there. So you've got boiling water, you pour salt, you pour salt, you pour salt, until no more will dissolve. Then you know it's 100% saturated. Let's say that took me 2 cups for a gallon of water. When I want to make 50% saturated water, then I would take 1 cup of salt to the gallon of water, and I know I would be 50% saturated. So this is very cheap to make salt water. So I always have a big jug of 100% saturated, a jug of 50% saturated. I also have a jug of 100% saturated and 50% saturated in the fridge. So I have cold, and then I also have room temperature. We're just going to focus on the room temperature, and we're going to try to answer the question, how does salinity affect density? Now, another part of this lesson, how does temperature affect density? I'm going to have you do that part at home. So you just need cold water, warm water, use any dye that you might have, and then see what happens. Okay, so you're going to use cold water, you're going to use hot water, dye one of them, see if you can get layering. All right, let's see. So how does salinity affect density? I'm going to just take a test tube, and let's see what happens when I start out with the tap water. Okay. And then I put the 50% saturated, and let's see. Now I'm going to squirt this, I'm going to put this in very, very peacefully. Okay, I don't want to put it in real forcefully. So I put the green in first, and then I put the yellow in, and you can see that the yellow went down to the bottom. The yellow, the 50% saturated, is more dense than the tap water. Let's put the 100% saturated in, and let's see where that goes. Put the 100% saturated in. Wow. The 100% saturated headed right to the bottom. Even though I put the green in first, the other ones went right below. Let's do another one where we actually put the 100% saturated in first. And then the 50. And again, you want to kind of put it in slowly. You don't want to smash it in there. And then let's put the tap water, which is not salty at all, on top. Oh, and again, I'm using my liquid watercolors, which I love. Remember, $3 buys you 8 ounces of this, or it buys you 1 ounce of food coloring. So you definitely want to invest in some of these. Now, I only had 3 colors. But if you notice, I have the 100% saturated, which is pink, and then I actually formed another color, orange. I've got the yellow, and I've got the green. With 3 colors, I made 4 layers. So what I would like you to do with your kids is do something like this. If you want to make it more challenging, have some cold also. So have 100% cold and 50% cold and see what they come up with. But asking the question, how does salinity affect density? The most dense, 100% salt. This is 100% saturated salt water. Another thing you can do with this idea is you can have a glass of salt water and a glass of regular water and crack an egg in it, and the egg in the fresh water will just sink to the bottom, and the egg in the salt water will float on top. Getting the idea of density in your student's mind. There's more stuff in the 100% saturated. There's more stuff. It's going to have more mass. It's going to go right down to the bottom like this did. So your question, how does salinity affect density? The saltier the water, the more dense it is. Now, in the oceans are very, very small percent salt. It's like 3.5%, okay, salt. I was using 100% salt. Imagine, how could there be differences in salinity in the ocean? Think about where there's lots and lots of ice, like in the North Pole. When water freezes, the salt does not freeze inside that water. Those glaciers are fresh water. They're not salt water, they're fresh water. So if you've taken a lot of the fresh water out, what does that mean about the water surrounding? It's more salty. So you get differences in salinity. At the equator, where it rains a lot, when water evaporates, it's fresh water. Salt does not evaporate into the sky. It's fresh water. When that rains down, now you have more water in that, and so that can affect the salinity. So these currents that are, again, look at the southern hemisphere, northern hemisphere, clockwise, southern hemisphere, counterclockwise. The little Ken experiment showing very, very rudimentary understanding of that. But it's a very, I once had a NASA scientist spend 5 hours with me explaining the Coriolis effect, and honestly didn't understand a whole lot more than I understand just using Ken and showing that demo. It is a very complex Coriolis effect. So the Coriolis effect that we talked about in winds is also responsible for the deflection here. Without the Earth spinning, these currents would not move in these directions. The currents would move straight in straight lines from the North Pole down to the equator, from the equator to the North Pole. They would move straight. They would not be deflected like this. This is, again, because the Earth is spinning, this happens. So we know there's differences in saltiness, but think about differences in temperature. What would cause differences in temperature? Well, we know the equator is in the tropics. Okay? we've got, right around here, we've got the Tropic of Capricorn, and we've got the Tropic of Cancer. And I always remember, because I know a lot of people with cancer, and I live in this hemisphere, so I always remember that, the Tropic of Cancer. So in the tropics, they are always getting very good quality sun. Remember I talked about in our winds lesson how we had two different lights. We had a heat lamp and we had a 25-watt bulb. The angle at which the sun hits this landmass is like that heat lamp. And the angle at which it hits us is more like that 25-watt bulb. But remember, it's the same sun. Because the Earth is tilted, we get different angles of sun. And they get a really good angle in here. Anyways, in the tropics, of course, the ocean in the top layers is very warm. And at the poles, of course, it's very cold. So these currents are driven by the desire for equilibrium. Everything is trying to get to equilibrium. And so we've got these thermo, meaning temperature, haline, meaning salt, currents. Thermohaline currents, which drive these, the movement of water, which for Northern Europe is fantastic because they would be so much colder. But they're not as cold as their latitude would say. Okay? The Gulf Stream, there's an interesting historical story about the Gulf Stream. Ben Franklin was the postmaster in England. And the mailboats would go from the US to England really fast because they were traveling in the Gulf Stream. But coming back, it took a lot longer. And the simple fishermen, the whalers, the people that made a living off the ocean, they all knew about the Gulf Stream. And they would see the Royal Navy ships, the fancy captains, struggling against that Gulf Stream current. But they didn't know about the Gulf Stream current back then. And so, because these were just simple people, they were just whalers or they were just fishermen, captains wouldn't listen to them. And it took way longer to get the mail from England to the US because they were going against the current. All they had to do was move a few miles out and they would have been out of the current and it would have been a lot easier. Just a little historical fact. Okay, so when we think about cold and warm, where do you think the most dense water would be? Think about saltiness. Saltiness makes it dense. Are cold things more dense or are warm things more dense? When your heater and your furnace is working in the wintertime, do you want to be on the floor or do you want to be a little higher up? Where is that heat? Does heat rise or does it sink? Okay. Think about what you already know. You already know that it's cold by the floor and it's warmer. It's really warm upstairs. It'll be real cold in the basement. Heat rises. So we know that warmer water is less dense. Colder water is more dense. So where would we find cold, salty water? Where would that water be? Where would it be more salty? Think about what I was saying about the glaciers, that fresh water. We've got the same amount of salt, but a lot of that water is locked up into fresh water. So you have some questions to answer. How do I combine temperature and salinity to make the most dense water, the least dense water? You have a little story about Ben Franklin and some benefits. Why is it beneficial? These currents are so important and beneficial to our animals. Okay? They're also important because they bring heat to places that wouldn't be hot enough. A lot of animals follow the currents in their migrations. Whales go and go to Hawaii, they go to Alaska, they follow currents, they follow food. Animals use the currents for transportation, they use it for food. The upwelling of cold water here is very important for fisheries and bringing nutrients to the surface. So these currents aren't just a nice thing that happens. They have very big significance. And what we're a little worried about with climate change is this ice melting, more heat, heat being absorbed by the ocean, water hangs onto that heat. It doesn't let it go. And so we're afraid some of these currents might be disruptive. And if they're disrupted, then the migrations of the animals that follow the currents, there's a lot of repercussions. Getting back to density, okay? You've got a few questions here. And I'm just going to say that the oceans, the saltiness of the ocean is almost been uniform since the beginning of the oceans, okay? The saltiness, the percent salt. But there are those little local differences, like at the North Pole where we have the glaciers, where we have more salt in the water. Those are slight differences. The difference in salinity is not caused by the saltiness. It's caused by water freezing or rain. So let's look at some of these questions. Rain increases the salinity of water, or evaporation increases the salinity of water? You got to think of it. Remember, rain is fresh. Temperature or salinity has the greatest influence on seawater surface density. I just said that throughout time, the saltiness of the ocean has been about the same. There's slight differences. Think about the temperature of the water when you're swimming in, say, Florida, near the equator. If you've ever been, by the equator, the water's super warm versus way up. So the differences in temperature are huge with seawater density. So think about, so which one would have the greatest influence? The one with the greatest influence would be the one with the greatest difference. Would there be a greater difference in the temperature of water between the equator and the North Pole, or the saltiness of the water? Variations in salinity are primarily the consequence of changes in salt or water content of the ocean. Okay, again, we're on that same idea. And the densest water in the ocean is found at the equator or the poles. You're going to answer those questions. Now, a little more about salty water. You may have heard of the Great Salt Lake or the Dead Sea. Some of you may have swam in the Great Salt Lake or the Dead Sea. Basically, there's so much salt in there that you can just float. You can just sit on the water. Some of you may have sat on the water at the Great Salt Lake or the Dead Sea. Why is that so much saltier than the ocean? Why aren't our rivers and lakes salty? That's water. Well, as the rivers and lakes are making their way, water that goes in a river and doesn't evaporate just keeps moving along. Will eventually move to lakes, will eventually move to rivers, St. Lawrence Seaway, eventually makes its way to the ocean. Water in the Dead Sea and the Great Salt Lake doesn't go anywhere. It gets in there, but there's no outlet. There's no going from the Great Salt Lake to something else. Because of that, the water, the salt and minerals that are in the water, because all our water has salt and minerals, all our water has stuff in it, but that's carried to the ocean, it's carried away. The Great Salt Lake and the Dead Sea, there's no outlet. The salt and minerals just keep accumulating, getting more and more concentrated, and that's why we can have these bodies of water that have very little, that have much, much more salt than the ocean, percentage of salt. So many great things about salt. There's so many great stories about salt in history. Gandhi started the independence movement in India because they were charging so much for salt, and he's like, let's just get our salt from the ocean. It's so interesting to look at history and try to bring history into science as well.